Welcome to this series with Aryan, a grade 8 student doing probability, which is a grade 11 course. Share the passion of learning, stay ahead of competition. That is the gift of education. You can ignite the spark of learning. Join Anil Kumar classes by sending an email on the address given here. Let us now enjoy the journey of understanding probability. Hi, Aryan. How are you doing?
I'm doing good, sir. How are you doing?
Very good, very good. So, today, what do you want to learn, Aryan?
Yeah, so I would like to just continue probability for like the first half of the class, and then afterwards we can start the functions unit which we started in class.
Great.
It's
That's good. So, we touched upon probability and we saw different cases and how the probability of events can be found. But now, getting more into probability and understanding the basic concepts, what you really want to know is counting principles. Because probability, as you know, is the ratio of favorable events to total number of events, right, in the sample
yeah.
space. So now it is the counting of favorable events and the counting of total events which makes all the probability work out better. So we will now look into how do we count these numbers which could be favorable or which could be just part of total outcome. Is it okay?
Okay.
So let me share with you a lesson which I have prepared on this. Okay. So can you see my screen?
Yeah, I can see it.
Right. So the topic here is combinatorics. So combinatorics is actually a branch of mathematics dealing with counting and arranging discrete items. Combinatorics applies mathematical operations to count quantities that are much too large to be counted in conventional way. Right. So that is the technique which we are going to learn. And
Okay.
probability, as you know, if you want to have probability of some event, we have to do experiments like thousands of times. We are always
Yeah.
working on a very large data set, and only then we can predict fairly accurately what is going to be the probability of an event, correct?
Yeah.
So, intrinsically, it requires counting for very large numbers. So, we'll look into these techniques. We'll cover some of them today. So, basically, we'll look into the counting techniques. So, let me just get into combinatorics itself, which we discussed. So, one of the counting principles, which we saw last time also, is kind of a tree diagram. So, here are few counting techniques which we will always come across. So let's take up an example. The example is Anil wants to go by bus, train, or by plane to either Detroit or Boston, right? So that is a statement. How many ways can this be done? So basically, we want to figure out the number of ways a path can be followed. And we have taken uh, two destinations and we have three ways of going through them, right? So bus, train, or a plane, and then we have two destinations, Detroit and Boston. When you are answering such questions, well, tree diagram is very handy and it clearly shows total number of paths as you can see right there. So you could either start with a bus or a train or a plane, right? And then after that, you could decide to go to Detroit or Boston. Total number of ways, as you can see, we'll call them as combinations, as six combinations, right? So that is to say, one combination could be go by bus and then to Detroit, by bus to Boston. So these are the combinations, six of them, which could be shown with the help of a tree diagram. Is this clear to you?
Yeah.
The other method, very convenient, is a matrix arrangement. So in matrix, you just make rows and columns as a table has, correct? So you have two options. You have to go to Detroit or Boston, and you have three ways to go through them. So we have a table, which is 2 by 3 table. And so you can see now the six cells within it gives you those six options, correct?
Yeah.
So very clearly, you can read the table that you can go by bus to Detroit. So that is Boston, Detroit, correct? By plane to Boston, right? So that is plane to Boston, which could be the path traveled like this. Is that clear to you? So that is how they are all interconnected, right? But
Okay.
knowing the techniques is very important since we can then decide based on the question or the situation which method to adopt. Perfect.
Yeah.
So what we could summarize from here is that the tree diagram is a simple way of representing a sequence of events. This followed by the other. You get the idea? This followed by the other. So when you have that kind of a statement, this followed by other, a sequence of events, tree diagram is a very good technique. However, I will recommend that if there are more than 3 layers, do not go for it.
Yeah.
So 2 to 3 is good for tree diagrams. Right.
Okay.
Now, what you also notice from the tree diagram is if we talk in terms of probability, for example, right? So, probability, if we connect, first we have 3 ways of going: bus, train, or plane, correct? So, let us say uh, there is no bias. Anil could take either bus or train or plane, and let's say they are equally likely. In that case, because there are 3 options, we have probability by going by bus as 1/3, correct? Let us assume that the probability of picking up Detroit or Boston is also 50-50, so that could be half. Now, going by bus to Detroit, the probability will get multiplied, and that be 1/3 times 1/2, which is 1/6, correct? So, out of 6 options, one favorable going to Detroit by bus. You get the idea. Same thing,
Okay.
correct?
Okay.
So, out of 6 options, there are total number of options which are 6 in number. And what is the probability of taking a bus and going to Detroit is 1/6, which you can also find by multiplying the probability of taking the bus followed by the probability of taking going to Detroit. Correct? So we call this as the rule of product. Is that clear to you? Rule of
Yeah.
product. So whenever we have events one after the other, in that case, we could apply this rule of product. It is a very important rule, easy to understand. Few constraints are, of course, there. And that is that this probability of taking the bus or going to Detroit should not change in your experiment, right? So we say that these should be independent events, correct?
Yep.
We know all these terms from our previous lesson, so it's easy for me to now communicate with
Yeah.
you and move forward. You see that? That's why
Yeah.
in the previous lesson, I kind of introduced to you all the terms, right? Including
Yeah.
independent, dependent, mutually exclusive, right? Conditional probability. So you are familiar with all those terms, right?
Yeah.
Just in case you want to know about them, you can always ask me, okay?
Yeah.
Right. So remember, if we have a sequence of events as we just had in this example, and they are independent, followed one after the other, in that case, we could use the rule of product. Very handy. So the process is made up of, in this case, 2 independent events. Travel mode, 3 options; destinations, 2 options, and therefore total number of choices, 2 times 3, 3 times 2 is 6. You get the idea.
Yeah.
This is the concept of combinatorics. Now, in combinatorics, I am not making a tree diagram. I am not making a table. I am concluding what should be the number, right?
Yeah.
Discrete number. I'm saying there are 3 ways of selecting a mode of communication, going, travel, and there are 2 destinations. So therefore, product rule will apply, and 3 times 2 is my answer. So I get 6. Now, if I make this like number of branches, layer after layer, I can just multiply those numbers and get my result. You get the idea?
Yeah. So basically, like, if we were just to say, like, what's the probability that, like, you're gonna go by a bus to Detroit, would that just be like 1/6 probability that you're going
If,
on a bus? Okay.
yes, if we have to give many conditions. See,
Yeah.
sometimes one may say that Anil favors to go by plane, right?
Yeah.
Maybe, right? So we have choices. So it all first we have to decide on one layer. What is the probability of picking a plane, train, or a bus, right? In this case, we are saying all are equally likely. Therefore, it is one third, one third, one third, correct? But
Yeah.
anyway, that has to be set. Now, similarly, the next destination is Detroit or Boston. And here also we are saying 50-50, so we know each probability. So the whole idea here is once you know individual probabilities, you could multiply them and get the result. You get the idea.
Yeah. Yeah.
So that is how it is very handy. And let's take more examples based on this multiplicative property, right, or combination. So this is also called the fundamental or multiplicative counting principle. This is the base, the foundation of counting principles. Is it okay?
Yeah.
So if a task or a process is made up of stages with separate choices, like we had, right? The total number of choices is product of each independent choice. Is this statement clear to you? With you because now on the screen I'm not there. So I'll stop sharing and then come back to the screen, okay?
Okay. Okay.
So Aryan, you're back. What happened?
Yeah. Yeah, so it's actually snowing here, and I lost power due to all the
Okay,
snow.
okay, let's
So
continue. Let's continue with our class. Okay, great. So we left somewhere here. We're talking about the fundamental or multiplicative counting principles, right?
yeah, yeah,
Okay, so at this stage, can you please read what is written here on the screen?
yeah. Fundamental or multiplicative counting principle. If a task or a process is made up of stages with separate choices, the total number of choices is product of each independent choice. M times N times P times whatever is where M is a number of choices for the first stage, N is a number of choices for the second stage, and P is a number of choices for the third stage, and so on.
And so on. So this is absolutely clear to you, right? We'll take up 3 examples to make it absolutely clear. First example, an ice cream parlor has 20 flavors with, there are 20 flavors, 10 topping options and 3 different size options. How many different choices is the ice cream parlor providing to the customer? So what will you do? Multiply 20, 10 and 3, counting principle. You get the idea.
Yeah, yeah,
So simple as that. We do not have to make a tree diagram or a table or anything else. These 3 are independent events which could be put in a sequence, one after the other, right? So 20 flavors, 10 toppings, and 3 different sizes will give us 20 times 10 times 3, 600 options from that ice cream parlor. Can you please read question number 2 and answer, please?
yeah. How many ways can you answer true-false tests consisting of 25 questions?
Can you answer this? Slightly tricky.
Yeah, that's
So there are 25 questions. For each
wait,
question, you could say either true or false. You have 2 choices. Do you get the idea? So for every question, there is a choice,
yeah,
which is, so let's look at it like this. These are my 25 questions. Question 1, question 2, question 3, and like this is 25th question, right? This is
okay,
question 1, this is question 2, question 3, and so on till question 25. Now, for each question, I have a choice. Either it could be true or false. You see that? So
yeah,
for every question, I have 2 choices. So one after the other, this becomes 2 times, 2 times, 2 times, so on
oh,
25 times. You get the idea.
okay, okay,
Very tricky question, looks very simple. So you see, it is 2 to the power of 25. Those are the number of options when you mark those true and false in 25 question multiple choice, true or
okay,
false. You get the idea.
yeah,
So each probability, each option is multiplied. Now, can you please read? Third question.
yeah. A standard die is rolled 5 times. How many different outcomes are possible?
Correct.
Yeah, and then yeah, this one is just I'm pretty sure 6 to the power of 5 because there's six
Correct.
different dice.
Every
Yeah,
time there are 6 options, right?
yeah,
So how many times is 6 to the power of 5? Does it make sense to you now? Correct?
yeah, yeah,
So that is counting principles. Now, directly we counted the number of options in this particular case. We could have indirect counting also, let us see what is indirect counting with the help of examples given here. Now, can you please read what is
Yeah.
indirect method?
Yeah. There are five pairs. There are five pair of gloves in a basket. In how many ways can two unmatched gloves can be pulled out from this basket?
Correct. Now we are saying that we have 5 pair of gloves in a basket. We have to pick up unmatched pairs, right? So one way is directly figure out how many pairs of unmatched, how many ways you can get unmatched pairs, right? That could be slightly difficult. How about thinking like this? How many ways can you pick out matched pairs? You get the idea.
Yeah.
That becomes easier because you know that there are only 5 pair of gloves, right?
Yeah.
So therefore, the strategy is we can find the number of ways of picking unmatched pairs of gloves by subtracting the number of picking matching ones from the total number of ways. You get the idea. So there are gloves and we have 5 pairs. That means there are 10 gloves, right?
Okay.
So we have 10 gloves. And how are we going to solve this question? So there are 10 ways of pulling the first gloves, right? So these are my 10 gloves, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that okay?
Yeah.
So when I'm picking up and pulling a glove, then I could choose any one of those 10, correct?
Yeah.
But when I have taken one, then I got 9 ways of picking the next one. You get the idea.
Okay. Yeah.
So I have only 2 picks. When I pick 2 picks, did I get matched or not matched? Now the question here is, now the question at this stage is, did we land up with matched or unmatched? You can say not matched with a counter like matched or not matched means I could write like this. Do you see that? So when I pick a glove, there were 10 choices for me. Then I picked up the next one, 9 choices from me. Do they match or do they not match? This is what we have to look into, correct?
Yeah.
So now see, the concept here is from the fundamental counting principles, the number of ways any 2 gloves is picked is 90. Any 2 gloves picked is 90 because first glove when I pick, I have a choice of 10 and for the second, I have a choice of 9 gloves. I have already picked one. So total number of choices is 90, right? Now
Yeah.
there are 5 matched pairs. These can be picked by first pulling out left and then right, or by first pulling out right and then left. So what we are trying to say now here is that there are only 5 matched pairs, right?
Yeah.
And in these 5 also, you will note that first you could pick left side and then the right side because both are different gloves, right? Right hand side and left hand side are different gloves. Is it okay?
Yeah.
Okay. So 10 ways of getting the match gloves because there are 5 match gloves, right? So if I pick glove number 1 right and I pick glove number 1's left, then it is one matching.
Yeah.
So there are 5 gloves, pair of gloves. So I could pick these 5. There are 10 ways to do it. Match pairs. 10 because there are total 5 and 2 options. First I could pick left and then the right, and the second option left and then right
Okay.
and then left.
Okay.
So there are 10 ways of picking up the matched. So unmatched is 90 minus 10, which is 80 ways.
Okay.
So again, as we are looking into this, sometimes counting becomes very difficult.
Yeah.
We need to really look into this problem in so many different ways to get to the solution. You get the idea?
Yeah.
So as you can see in this particular example, it was easy, I should say easier to figure out the number of ways for picking the matched pairs out of those which are available to you. correct?
Yeah.
And then subtracting from total number of options, we get the unmatched. So that is what we say indirect method of counting. Is it okay?
Yeah. Yeah.
Now, we talked about the product method. Let us take into account another method which is called the sum rule. Sum is like when we have options with or condition, this or this. Product was an option with and. I will go by bus and then go to Boston. You get the idea. So and condition makes product, or condition is sum. Can you please read what is written on the screen?
Yeah. Additive counting principle or sum rule. If you can choose from either m items of one kind or n items of another kind, then the total of ways is m plus n times additive counting principle. Note the events m and n are mutually exclusive as they cannot happen at the same time.
Correct. So what we are now saying is that, let us say this is one set. You have to pick up from here, right? Let's say we have boys here, right? And this is another set, girls.
Yeah.
Now, if you want to figure out how many boys and how many girls are taking mathematics, for example, correct? Now, if we know the number of boys taking mathematics and number of girls taking mathematics, we could just add them, correct? So that is what basically adding principle is, or the sum rule is. Is that clear to you?
Yeah.
Okay, here is an example for you. How many ways are there to select a king or a blackjack from a standard deck of cards? Correct?
Okay. Yeah.
So can you answer this question?
Isn't it just 6 because there's 4 ways of
Correct.
like
So
yeah,
4 kings and 2 blackjacks, right?
yeah.
So that is how we can figure out. You just added them together, correct? So this is what the addition rule is. Now, many cases, what we have is combination of product and addition. This is where things really become complicated, correct? So let
Yeah.
us take up an example where we could have combination of product and the sum rule, right? So
Yeah.
here's an example for you. How many different signals are possible with set of 4 distinct flags? Let's say they have different colors, blue, red, green, and yellow. If a minimum of 2 flags is used, you understand?
Yeah.
So let's say we have these flags, right? And we have 4 distinct flags of different colors. And we are saying that the colors are, let me just put blue, red, green, and yellow, right? So when we take at least 2, we could take 3 and we could also take 4. You understand now? So
Yeah.
when I say if minimum of 2 flag is used, how many signals can we send? You get the idea?
Yeah.
So now we have options. Options are that we could take 2 flags at a time, we could take 3 flags at a time, or we could take 4 flags, all of them together at a time. So these are independent options. They do not have anything common, correct? Mutually exclusive.
Yeah.
So in this case, all these individual options will add up to get the total number of options. You get the idea?
Yeah.
So now, solving such questions, the strategy is we now follow cases. Case 1 is we have 2 flags. Case 2, we have 3 flags. Case 3, we have 4 flags. Now, we have in all how many flags? 1, 2, 3, 4, right? If I am doing only 2 flags, let us take the first case of 2 flags. That means I am showing you 2 flags. In how many ways can I pick up the first flag? Because there are 4, I can pick up this first flag in 4 ways, correct?
Yeah. Yeah. And then
Once I have picked up 4 flag, 3 are left. So the other option is 3. When I multiply, I get 12. So if I am creating signals with 2 flags, there are 4 times 3, 12 options, right? Now I decide the second case. And in the second case, I am taking 3 flags. Well, first flag, 4 options, second flag, 3, and the third flag will be 2 left. And therefore, the number of ways where I can produce the signals using 3 flags is 24. 4 times 3 times 2. We applied the product rule, correct? Last case here, all four, one left. So that will be the one left. And when I multiply all of them, I get 24. So using 2, 3, or 4 flags, we could have 12, 24, or 24 options. And total is how much? We have to add them all, correct? So that is how we do the combination of product and sum rule. And the answer will be 12 plus 24 plus 24, which is equal to 60 signals.
Okay.
Is this clear to you? Aryan, is that clear to you?
Yeah. That's good.
Correct. So we will actually end our class today at this particular stage. I'd like you to summarize our learnings on combinatorics. Aryan,
Okay.
can you summarize what did you learn about combinatorics? How do we count?
Yeah, so basically in Jay's class, we went over the different types of counting properties and the different principles for probability, and just practice and like kind of like dig deeper into like the meaning of probability and like all the counting principles in general.
Correct. So you understood when to apply the product rule. You also understood how do we apply the sum rule and the combination of two. So those few examples gave you the foundation for the basics of counting in such scenarios. So I'd like you to check out some of my videos and do some practice questions on these counting principles. And we'll next class go further into details on combinations and permutation.
Okay.
Is that okay? Right.
Yeah.
So this is where we are going to end today's class on combinatorics. Now you want to do what? Functions, correct?
Yeah, functions. Yeah.